Hello, everyone. Thank you all for listening. Today, we're diving into a critical issue in mobile privacy, the gap between what apps say they do in their privacy policies and what they actually do. Our focus is on Polycheck, a groundbreaking tool that exposes hidden data flows by answering a simple question: who's receiving your data? Let's get started. Let's start with the problem. Imagine downloading a game that claims to collect device identifiers, but secretly sends your IMEI, a permanently hardware ID, to advertisers like Tapjoy. This isn't hypothetical. Our study found that 42.4% of apps either omit or lie about such data flows. Why? Because existing tools ignore the who, the entities receiving the data. We'll see a policy saying we collect device IDs and call it consistent, even if your IMEI goes to a third party. That's like a restaurant menu listing meat, but serving you mystery meat from unapproved suppliers. But why should we care? Let's talk about these stakes. First, user trust. If an app says it doesn't share your data, but it does, that's betrayal. Second, compliance. Laws like GDPR and CCPA require apps to name exactly who gets your data. Snapchat learned this the hard way, with a 157 million FTC fine for vague policies. And finally, business risk. Fines, app store bans, and reputational damage. Ignoring entities isn't just lazy; it's legally reckless. Reckless. So, what makes this so hard to fix? Three hurdles. First, technical. Mapping domains like ws.tapjoysads.com to entities like Tapjoy. Second, semantics. Policies use vague terms like third party or device information. Third, scale. Analyzing 45,000 data flows across 13,000 apps. Imagine comparing a privacy policy's vague data sharing claim to actual flows like IMEI, Tapjoy. It's like matching a blurry photo to a fingerprint without the right tools. It's impossible. And you can see this Venn diagram here that shows the gaps between policy terms and data flows. So under policy terms, we have device identifiers, third party, analytic providers, data sharing. Then under actual data flows, we have IMEI, Android ID, Tapjoy, Unity, and AdMob. Enter Polycheck, our solution to this puzzle. Polycheck's core idea is simple: entity-sensitive consistency. It checks not just what data is shared, but who gets it. It combines three key components: dynamic analysis, so this is via app consensus, to catch real-time data leaks. The second one is policy parsing via PolicyLint, to extract entities and data types, and ontologies, to map vague terms like advertiser to specific entities like Tapjoy. Think of it as a translator. It turns policy jargon like we share data with partners into concrete facts like IMEI sent to Facebook. So let's now break down how this works by step by step. Methodology. Step one is dynamic analysis, which is app consensus logs data transmissions, like catching an app red-handed sending your IMEI to Tapjoy's server. Step two is policy parsing. NLP extracts statements like we share device IDs with advertisers and flag negations like we do not share. Step three, ontological mapping. This is where policy check shines. It links domain like unity3d.com to Unity and understands that advertisers include Tapjoy. Without this, vague policies stay vague. An example. For instance, if a policy says analytic providers collect device data, policy check knows that includes Flurry collecting Android IDs. So now, how does Polycheck classify disclosures? There's 5 disclosure types. Polycheck sorts disclosures into 5 types, and let's walk through all of them. The first one, clear. The policy says Unity collects ID ads, and it does. rare, only 0.5% of flows. The second one is vague. Third parties collect device data. This covers 49.5% of third party flows. The third one is omitted. No mention of sending IMEI to Avazoo. And then the fourth one is incorrect. Policy denies sharing but does it anyways. And then the last one is ambiguous. Contradictions like we share data for ads versus we don't sell data. These categories let us pinpoint exactly where policies fall. Let's see how ontologically power this classification. Ontologies are hierarchical dictionaries. For data types, device ID includes IMEI and Android ID. For entities, third party includes advertisers like Tapjoy. When a policy says analytic providers collect device identifiers, policy check maps that to a flurry receiving Android IDs. Without this, we miss the connection, like calling a wolf a dog because they're both canaries or canines. Trans how did we test this at scale? So here's the experiment setup. In this experiment, they analyzed 13,796 Android apps and 45,603 data flows. Tools like App Consensus decrypted TLS traffic to capture real leaks, while PolicyLint parsed 218,000 policy statements to validate. We manually checked 153 flows. Policy checked achieved 90.8 precision. It's like a doctor correctly diagnosing 9 out of 10 patients. So, what did we find? These are the results, and they're stark. 42.4% of apps had omitted or incorrect disclosures. 49.5% of third-party flows use vague terms like third party. 38.4% of prior tools consistent labels were false because they ignored entities. For example, prior work would call a flow consistent if the policy said we collect device IDs, even if IMEI went to Tapjoy. Policy check fixes this, reducing false positives by 38%. And here you can see these heat maps which show rare, clear disclosures versus common vague ones in all three of them. And now we can take a look at real world offenders. And here they are, case studies. So for the case one, a children's app, Furby Boom, claimed it didn't share device IDs but sent IMEI to Unity. This violates COPPA, risking kids' privacy. Case two is flip diving. This had contradictory policies. We share data for apps versus we don't sell data. Is it sharing or not? Policy check flags this for ambiguity, urging clarity. But who benefits from fixing this? Regulators like the FTC can automate audits. Developers can audit SDKs, Unity, Tapjoy, and rewrite policies. App stores like Google Play can integrate PolyCheck to block shady apps. Imagine a world where what policies mean what they say they are. That's PolyCheck's promise. Conclusion, limitations, and future work. To wrap up, 42.4% of apps misrepresent data flows. PolyCheck closes this gap with entity sensitivity. Developers audit your SDKs. Regulators adopt tools like PolyCheck. Let's make privacy policies reflect reality, not hide it. Thank you.